Good morning. So we're gonna dive right in here after I sneeze. Um, this lesson is all about simplifying expressions. Now, before we can get into that, you need to understand the word term. So, in an expression, when we say term, let me draw an expression for you. When we say term, we simply just mean the terms that are separated by plus or minus signs. They're things separated by pluses or minuses. The long definition is that it's a single number, a variable or number in variables that are multiplied and divided by each other. Quick, easy thing, separated by pluses and minuses. So this is one term right here, my 3x. This is one term, 2y. This is one term, my 4. Okay, now this 4 here is actually, we're going to keep change, a negative 4. Okay, so that's what a term is. Now, what do I mean when I say like term? What does it mean for one of these to be like? So like terms are terms whose variables are the same and the exponents on those variables are also the same. Now we have an example here. So again, the variable is the same and then the exponent on the variable is the same. So I have 7x. So my variable is an x. And then here I have an x as well. My exponent, there's none there. My exponent, there's none there. Now when there is none, that just means there's an exponent of 1. So I could draw in a 1 that if I want. But these are like terms because they both have an x, and they both have an exponent of 1. Another example could be like 2x cubed and 1/2 x cubed. Again, my variable is the same. They both have an x. They both have an exponent of 3. Therefore, they're like terms. Now, if we look over here at the non-example, this one has an x, this one has an x, but this one has an exponent of 2. This one has an exponent of 1, or no visible exponent. So those exponents are different, and that's what makes them non-examples. Now, why does this matter? So this matters because only like terms can be combined. And like I said, today's lesson is all about simplifying expressions. And simplifying means we're going to take something big and make it into something smaller. In order to do that, we have to combine a few things. And that's where the like terms come in. We're going to combine them and make two things become one to make it smaller. So let's go through some examples here. So again, there's two things we need for like terms. They need to have the same variable with the same exponent. So let's draw a circle around the terms that can be combined with 3a. So I'm looking for an a with no exponent. There's an a with no exponent. That one works. That's a b, so that doesn't work. That's an a, but that one has an exponent of 3, so that's no good. There's an a with no exponent, but it also has a b attached, so that's not good. Okay, it has to be just an a by itself. The fact that there's a b with it means that that doesn't match either. Let's see, there's no a there at all. There's an a with no exponent, so that's good. That's a b, no exponent, a b, and a. That one has an exponent of 2. Again, I need one with no exponent, so that doesn't work. And then again, an a with a 2. So that one's done. Go ahead and pause me when I say go. I want you to draw a square around ones that can be combined with 4b. Underline ones that can be combined with a squared. Draw an x through ones that can be combined with 5. Okay, so find the ones that can be combined with 4b, draw a square around them, and then do the other two as well. Remember, you're looking for the same variable, same exponent. Pause me and go. Okay. Hopefully you went and did this. I'm drawing a square on the ones with 4b. I have 3b because there's just a b, and they both have no exponent. Just a b with no exponent. That one's good. I'm looking for an a with a little 2 exponent. And then an x that can go through ones combined with 5. So that one has no variable, no exponent. Ooh, so 17 and 100. Okay. Now we know like terms. Now let's talk about the steps to actually simplify. So I told you that we have to combine those. We're going to combine like terms to make it like one thing, to make it smaller. How do we do that? So we first want to make sure we change subtraction to addition. That's by doing change. And then we want to complete the distributive property if necessary. We'll talk about that. And then we're going to identify all like terms. And then we're going to combine of the like terms, but leave the variable and exponents the same. So I'm just going to quickly do an example of this because that's a lot. So combine the coefficients of the like terms. So I'm going to draw a 2x squared plus a 3x squared. These are like terms because they have the same variable and they have the same exponent. They both have a 2. So they're like terms, so we identified that they are like terms. Now step 4, to combine them, we're going to combine the coefficient. Now remember that the coefficient is just the letter that's in front of your variable. So we're going to combine those and then leave the variables and exponents the same. So I'm going to combine my 2 and my 3. 2 plus 3 is 5. I'm going to leave the variable and the exponent the same. X with an exponent of 2. That's a small example. So now let's put this into actual practice. So step 1, change subtraction to addition. So I'm going to addition of the opposite, or keep, change, keep, change. Now I can identify like terms. When you do these problems, I'm going to be looking for you to draw shapes around them, just like we did up above in the practice. So I'm going to start with an M. So I have 14M here. That's an N, so that doesn't work. Remember, we need matching variable and exponent. That's an N, that's an M, that's an M, and they both have no exponent, so that one goes. Notice how I'm circling the addition sign with it. That's very important because that tells me it's a positive 3. Okay, now I can draw squares around my ends. Again, notice how I'm making sure I include that negative sign. Okay, and now we can combine. I have 14M and 3M. 14, 15, 16, 17. That gives me a total of 17M. And then I have negative 3 and negative 2. So negative 3, take away 2 more, means I'm going to have negative 5. Keep the variable the same. Keep the exponent the same. And that's my final answer. I know that's my final answer because this is an M right here, and this is an N right here. They're different variables, so I can't combine them anymore. When you have 2 different things left, there's nothing else you can do, so you're done. All right. Let's go ahead and do this one. Go ahead and pause me, and I want you to try doing this one when I say go. So remember to keep, change, or subtraction to addition. Remember to draw shapes around your like terms, and then combine them. include the signs when you draw your shapes. Okay, go ahead and try and pause me. Okay. Now, keep, change, change, keep, change, change. So I have a negative 6x and a negative 8xy over there. Okay, so we did that. Now we're going to draw shapes around my like terms. I'm going to start with this one. I have a 4x. So I'm looking for other ones that have just an x with no exponent. That's a y. There's an x. Again, notice how I'm making sure I have the signs with it. And that's a y. That one's an x, but it also has a y. So that's not good. Okay, now let's do the next one. I have a plus 5y. Again, notice how I'm drawing it around the sign, around my plus sign. What can combine with y with no exponent? Another y with no exponent. And then lastly, 8xy, that's my last term. There's nothing else that goes with it, so that's going to be all by itself. And now we can combine. I have 4x plus a negative 6x, which will give me a negative 2x. I have a 5y plus 7y, which would give me 12 total y's. And then I had nothing else that could combine with the x and y, the 8xy, so that'll just drop down and stay the same. And again, I know that I'm done because this one has an x, that one has a y, so those can't be combined. That one has an x and a y, but none of these have both. So I'm done. Nothing else is like terms. That's it. Now, the last one I'm going to quick go over, this is like a problem in your homework that you have due today. So find the perimeter. Perimeter just means your distance outside. So we're going to find the distance all the way around our shape. So if this side is plus 1, this side is 2m minus 1, how long is this one? Hopefully you said, oh, it's the same as that one, and it's m plus 1. So that means this side is how long? 2m minus 1. Same as this side. Okay, so perimeter means your total distance outside. So what do you think I'm going to do with all of these? Hopefully you said, oh, nice, I'm going to add them together. And you'd be right. So I'm just going to write out m plus 1. That's side 1. Side 2 is 2m minus 1. Side 3 is m plus 1. And side 4 is 2m minus 1. So we added side 1, side 2, side 3, side 4. And now we can combine them. I'm going to go through and keep, change, change, subtraction. And now draw shapes around my like terms. I have an m, I have a plus 2m, a plus m, and a plus 2m. I have a positive 1, a negative 1, a positive 1, and a negative 1. Let's go ahead and combine the m's first. M plus 2m gives me 3m, plus an m is 4, plus 2 more is 6m. And then I have plus 1 minus 1 is 0, plus 1 is 1, minus 1 is 0. So that's my final answer. Okay, I know there's a lot more to these notes down here. We're going to be re-going over all of this stuff today, so don't worry about that. Just make sure you understand how to do this part, combining your like terms. All right, have a great day.